Yeah, good morning, every one of you. So today we are going to start this unit 1, which is nuclear materials, explosives and propellants. So next 10 to 12 classes we will be using to cover this unit 1. So better to learn, preview and then come and then listen and then go and review once again. Okay, well, once again repeat, preview, listen and then review is the best procedure to learn anything. Okay, for engineering subjects especially, it is very good to follow that procedure. So as yesterday I have just going through this syllabus. So once again I will repeat the syllabus of this unit 1. So in this unit 1 there are two parts. One is nuclear materials and next one is explosives and propellants. So part A will be the nuclear materials entirely. So in this one, a general introduction about the nuclear materials. Okay, what is the atom, what is nucleus, what is nucleon, what is neutron, what is proton. Okay, what is the mass number. Okay, you might have studied this in the earlier classes, but I will once again quickly revise those one in the introduction, and some of the pioneers who have worked in this nuclear physics, okay, in India, especially in India, regarding them some details I will give. So there is no point in discussing about them here. There is nothing available in your syllabus, but out of my interest to share the knowledge about them, the veteran people who have worked, pioneered the work. Okay, to remember them once again, I am just giving some introduction or some a brief profile reading of the veterans. Okay, then next is the reasons why we have to study for nuclear energy. So what is the energy spectrum for India? Okay, what is the economic justification of nuclear power? Why, apart from conventional energy sources like hydro power generation, steam power generation, why we have to use this nuclear energy instead of that conventional sources? What is the economic sources? How advantageous this one? We will be discussing in detail. Then nuclear agro-industrial complex. So this will be a complex in which a complex flow sheet in which there will be the many units like power generation will be there, water purification it will be there, then this purified water can be used in the agriculture purpose, then pesticide industries will be there, fertilizer industries will be there, all together will be there in the one simple place. Okay, that is called as a nuclear and agro industrial complex, that is called nuclear nuplex, we will say in the short form it is called nuplex. The next topic will be the energy via nuclear fission reaction. There are two types of reaction. One is fission reaction, another one is a fusion reaction. Okay, generally fusion reaction will be happening naturally from our sun, whatever the heat we are encountering, that is due to the fusion reaction. But in the nuclear energy production, we will be using the fission reaction. So what is the difference between this fission and fusion reactions? We will be discussing in detail. Then the next topic will be role of chemical engineering nuclear energy. So in the nuclear energy production, nuclear physicists will be largely involved. So what is the kind of role that as a chemical engineer we have to play there? We will be paying a special emphasis on this topic. Then the next topic will be important components of a nuclear fission reactors. Okay, whenever there is a reaction, nuclear fission reaction inside that one, there will be certain components. First one is we want a fuel inside that one. There are two types of fuel. One is a fertile fuel, this one is a fission fuel. So what is the difference between the fertile fuel and fission fuel? We'll be discussing in detail. And various structural components of a reactor, like moderators will be there in order to lower the neutrons outgoing. Okay, not to suppress the neutron outgoing tendency of that particular reaction, we will be using a moderator. Then absorbents, coolants, fuels. Okay, nuclear energy is a high energy reaction. Okay, highly exothermic reaction. To cool that one, we have to use coolants and various fuel cell. A complex fuel cell we will be showing in detail in the flow sheet. Then methods of production of uranium or of nuclear material like uranium or thorium or plutonium, neptunium, all this will be there in a trace element, in a trace concentration, in a very trace composition, it will be present on the earth. So that will be concentrated first, then purified and then converted into some useful form like a fission form. So we'll be discussing in detail about these topics. These topics are there in your part A, which is nuclear materials. Then the next one will be the part B, which is about the explosives and then propellants. We'll see later that one. First, just cover this part A, which is nuclear materials. So what is the nuclear power? First of all, what is the nuclear power? So nuclear power is nothing but using some nuclear reactions, okay, a fission reaction. So whatever the exothermic energy which has been liberated by that compounds, nuclear materials, okay, that exothermic reaction heat will be utilized in order to send that heat to the steam turbine. Thereby, it will be producing an electricity. That kind of process is called as a nuclear power generation units or nuclear power plant. Okay, we need a heat to generate a electricity, so that heat will be released by the nuclear reactions, okay, fission reactions, in which nuclear materials will be used. Due to this exothermic reaction, a large excess amount of energy will be released or heat energy will be released. That heat energy will be used in some turbines. Thereby, that turbines, due to the mechanical energy, mechanical deflection of the turbines, we will be generating an electricity. So that entire process is called as a nuclear energy generation or nuclear power plant operation. So nuclear power can be obtained by nuclear fission reactions, nuclear decay reaction, or nuclear fusion reactions. So presently, the vast majority of electricity from the nuclear power is generated using nuclear fission of uranium and plutonium as a nuclear materials. Only fission reactions we are right now we are employing, whereas possibilities are there to use this nuclear decay reaction, also the fission reaction, but largely we'll be employing this fission reaction. What is the advantages of this fission reaction or the fusion reaction? What is the difference between them? We will see later that one. Then what are the advantages? Why we have to generate our electricity using the nuclear power only? Okay, what is the role of this nuclear power in nuclear energy in our electricity? We will be discussing here. That is the advantages. What are those advantages? So they will be relatively low cost compared to the conventional sources of electricity generation. The cost will be somewhat low here. Then low pollution. So obviously we are operating all the nuclear power plants in a controlled environment. So the pollution will be very low, and thorium as an alternative. So largely see as nuclear materials, there are many nuclear metals like uranium, plutonium, neptunium, thorium, all these are there. But the fission fuel directly which can be used in the nuclear reactor is a uranium. Okay, fissionable form of uranium. But availability of uranium in our mines are very, very limited. Okay, but in India, largely thorium is available. Okay, if thorium can be converted to fissionable fuel once again, can be converted to uranium once again. So that process, we can alternatively, thorium can also be employed as a raw material in the nuclear energy generation. Okay, that makes the advantage over the other processes. Then it is very much sustainable. Very small mass of this nuclear material is enough to generate a huge amount of electricity, whereas there's a steam electrical generation, steam power plants or this hydrothermal power plants, okay, whatever this reservoirs and everything, they will be costing more, as well as they are not at all sustainable. If water is not there, how can we generate electricity from the hydrothermal plant? If there is no enough heat generating capacity in the power plant, steam power plant, then it can't be sustainable further. So the nuclear energy, it is very, very small mass of nuclear material is enough to produce a vast megawatts of energy. So that's why it is making as a sustainable energy. Nuclear energy is a very much sustainable energy. So it is called as high energy density fuel. It will give a high energy density for a small fraction of nuclear material. It is enough, that much fraction is enough to generate a vast amount of nuclear energy, nuclear power. But there are obviously, for every process, when there is a advantages means there will be a disadvantages also. Okay, what are the disadvantages in our nuclear energy? So accidents might be happening. Okay, accidents are inevitable in the nuclear power plants. We have to be very careful about the accidents. Whenever the disasters or these accidents are happening, that will be a very heavy magnitude compared to the conventional power plants. The accidents which are taking place in this nuclear power plants will be impacting very much on the humankind. Okay, there are many accidents are there. Okay, that accidents we will see in detail that one. Just quickly I will introduce them. So first one will be the Chernobyl disaster. Okay, this has been happened in the Ukraine. Okay, Ukrainian, European, North European country. This is there. This Chernobyl accident has been happened. How this has been happened? Due to the flaws in the nuclear reactor design or simulation. Due to that flaws, it has been happened. Okay, after happening this type of incident, it is considered as very heavy disaster, level 7 disaster, which has happened in 1986 in the Ukraine. Okay, This was happened in Ukraine. This is the Chernobyl disaster, popularly known as Chernobyl disaster. After this disaster, Chernobyl disaster, there is one more disaster which has been happened in 2011. That is in Japan. So that is called as a Fukushima Daiichi nuclear disaster, which has happened in this Japan country, Japan. According to this International Atomic Energy Agency, popularly known as IAEA, International Atomic Energy Agency, which is there in the Vienna, Austria. Okay, according to that agency, International Atomic Energy Agency, this accident is classified as level 7. Okay, level 7 accident means you can see here. So this IAEA classification, there are many levels from the 0 level to up to 7 levels are there. So all these levels from 0 to 3, it is an incident. Okay, you may know the difference between the incidents and this accident. Okay, some small incidents will be there. Depending on what type of accident that is, they will be classifying what is the level of that incident or accident. So until the level 3, it is a incidents. Okay, just one simple incidents or some serious incidents. So for example, first one is some deviation. Okay, deviation in some operator setup or reaction setup or something like that. Then next one is some serious anomalogy. Then second level 2 will be the incident, a small incident. Then a serious incident will be classified as a level 3. Then the level 4 will be the accident. From level 4 to level 7 will be the accidents. So accident with local consequences only up to a certain diameter or certain radius of this earth, it will be affecting that one. It is very much local, not international consequences it will have. Then level 5 will be the accident with wider consequences. So it will be affecting wider number of people. Then very serious accident, which will be classified as level 6. And the major accident will be classified as level 7. So the impact will be very high whenever it is happening in the major accident classification. So according this Fukushima Daiichi nuclear disaster has been happened in 2011 in Japan, in the country Japan. It has been classified as a major accident according to our IAEA. So level 7 accident, this one is the major accident after this accident, Chernobyl disaster, which has happened in 1986. After 1986, this was the major accident which has been happened in 2011. So primarily whatever this the reasons behind the happening of this particular incidents will be, the former is the failure of the reactor here. In the Chernobyl disaster, failure of the reactor number 4, they are showing as a flaw due to the design flaws in the reactor as well as simulation flaws in the reactor. But in this Fukushima Daiichi nuclear incident, what happened? Due to the earthquake and tsunami, okay, initially there is a shutdown of some reactor, some active reactor has been shut down. Due to the shutdown of that reactor, this accident has been happened. But the main trigger for this accident is a natural disaster, which is a tsunami and earthquake. But the former is previously due to the design flaws in the reactor. So this was the major two accidents which has been happened in the nuclear energy power generation. Okay, then these are the various disadvantages. One is the accident. The next one is whatever the radioactive waste which has been coming out of the nuclear energy power plants. The disposal of that one is very difficult. Okay, we cannot as such we cannot throw that radioactive material. Since they are radioactive materials, they will be releasing some radioactive rays, the radioactive radiations it will be emitting, that will be impacting the surroundings. So because of this, a proper and a suitable and a sustainable radioactive waste disposal mechanism we have to be selected here. Okay, there are two disadvantages. One is accidents will be happening. Then next one is the radioactive waste disposal is very heavy in this nuclear power plants. But apart from this one, the density, the nuclear power density will be very high. It is very much sustainable. We can use a alternative available nuclear materials as a alternative, like a thorium alternative, and it is less pollution compared to the normal power plants. Then it is relatively low cost compared to the conventional or a traditional power plants. So these are the various advantages and disadvantages of a nuclear power. Then the nuclear materials. What are the nuclear materials which are available? So according to this IAEA, I already told you, this is International Atomic Energy Agency. IAEA means International Atomic Energy Agency, which is in Vienna, Austria. Okay, according to the IEEA, the nuclear materials are nothing but uranium, plutonium, and thorium are the nuclear materials. So, what is there inside that material? So, this material will contain some huge mass inside that one. Whenever they are bombarded, whenever they are happening a reaction, that will be some chain reactions that will be releasing some energy, okay, some exothermic energy. Due to this release of this exothermic energy or heat energy, that heat will be utilized in a steam turbine so that the electricity can be generated. But whenever there is some mass, so inside that mass we can be denoting it as some atoms. Okay, when you take some small chalk piece, okay, the particles which are tiny particles which are just emitting by that just releasing by that chalk piece is called as an atom. That is a simple example for that atom. So what is the atom which is composed of? What is an atom? You might have seen this definition of atom in our physics classes. You might have seen this one. So what is the atom? Okay, atom is nothing but which is composed in at the midpoint of this atom. There will be a nucleus. Okay, what is this nucleus? So this is called as atomic nucleus. Is a very small, okay, dense region. Atomic nucleus is nothing but a very small dense region of protons and neutrons. At the center of the atom is called as a nucleus. Nucleus is composed of protons and neutrons. Then what is the protons now? So this is nothing but a stable subatomic particle, okay, occurring in all atomic nuclei with a positive charge. Positive electrical charge is called as a proton. So proton will be having a positive electrical charge. So usually these protons, what happens? They will be equal in magnitude with respect to the electrons, but the charge will be different. Electrons will be having a negative charge, whereas protons will be having a positive charge. Nucleus is composed of protons and neutrons. Protons is a positively charged particles, subatomic particles, we can say. Then what is about neutron? So neutron is also a subatomic particle with no net electrical charge, and it will be having a slightly higher mass or a greater mass compared to the protons. So nucleus is composed of protons and neutrons. Neutrons will be the neutral charge and protons will be the positive charge. So all together this nucleus will be located at center of any atom. So there will be a revolving electron nucleus. Electron cloud will be there around this nucleus. So that is called as a electron cloud. So what is this electron? So the electrical, what we say, this electric force between the charged bodies at rest is called as a electrostatic force. All we can say simply the Coulomb force. So this electrons and this nucleus, whatever the nucleus is there, they will be intact. How they will be intact? Due to some electrostatic force. So that electrostatic force is nothing but an electrical force between charged bodies at rest is called as electrostatic force, or simply we can say that is Coulomb force. Then what is the electron? So electron is nothing but a stable subatomic particle occurring in all atomic nucleus with a net negatively charged, net negative charge. So electrons are the negative charged subatomic particles and the stable particles. Then these neutrons are the neutral charged particles. Then protons are the positively charged particles. All together, this neutrons, electrons, protons, all together will be associated intact with each other in the atom due to the electrostatic force. So electrostatic force is nothing but the charged body. The electric force between the charged bodies at rest is called as a electrostatic force, or simply we can say it is a Coulomb force. Okay, the electrons will be in an equal number. Usually they will be in equal number compared to this protons also. So as shown in this figure here, see there is no charge in the neutrons. The protons will be having a positive charge and electrons will be having a negative charge. Okay, this is about the nuclear power, a general introduction of the nuclear power. So until now, if you have any doubts or anything you want to know more about that one, you can ask me that one. So simply we can define what is an atom. From this nuclear, neutrons, protons, electrons, we can define an atom. So an atom is nothing but which is composed of a positively charged nucleus. So here they see the nucleus is composed of protons and neutrons. So protons will be positively charged, neutrons are neutral charged. So the net positive charge of this nucleus will be a positively charged. So atom is composed of an positively charged nucleus with a cloud of negatively charged electron which is surrounding around the nucleus. So it is bound together using some electrostatic force. So it is the smallest constituent unit of any matter that has a property similar to the chemical element. So any element if you take, so it is its smallest unit will also have the same properties as that of a big mass of that big cluster of that particle, the cluster of that constituent matter. So atoms are extremely very small. So example for this atom is just to take a piece of chalk piece. Whenever I am writing on the board, so the small tiny particles which are falling on the ground is nothing but your atom. So inside that atom there will be many things are there like neutrons, protons, electrons, all this will be there. So atoms will be very tiny. They are very extremely small, and typically the sizes of the atoms will be around 100 picometers. So nearly this 100 picometers will be equal to 10 power minus 12 meters. Okay, 10 to power minus 12 meters. So from this atom definition only, there is a atomic number. You might have seen in the periodic table of elements. What is the atomic number? Okay, what is the molecular weight? Everything which has been defined from this definition of atoms, protons, neutrons. Okay, all this together counting is known as this atomic number. So what is this atomic number? So the number of protons within the atom's nucleus. So the number of protons within the this atom's nucleus is called as an atomic number. So the number of protons within the atom's nucleus is called as atomic number and is equal to the number of electrons in the neutral atom. So as I said you, the magnitude of this protons and this electrons will be nearly equal. So in the neutral atom, it is also equal to the number of electrons. So simply we can define what is the atomic number. The atomic number is nothing but the number of protons within the atom's nucleus is called as atomic number and is usually equal to the number of electrons in the neutral atom. So this is called atomic number. This is how we will define the atomic number. So hydrogen atomic number 1, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, how we are defining according to their number, atomic number. So using this type of definitions only, we are framing that one in the periodic table. So the sum of the neutrons and this protons. So sum of the neutrons and protons with the nucleus within the nucleus is called as a nucleons. We will say this one NuCleons, nucleons. So nucleon is different, nucleus is different. Inside the nucleus, there will be the protons and neutrons, okay, with their respective charges. But nucleon is nothing but sum of the protons plus neutrons is called as a nucleons. So here we can define this one, isotopes. What do you mean by isotopes? So the particular element, okay, particular component will have some chemical element or component will have a isotopes of their forms, okay, different isotopes, different forms of their elements. So that is called as isotopes. How can we define technically that one? So the variants of a particular chemical element which differs in their neutron number. So they will be having a shape, same shape, but the neutrons which are there inside that particular isotope is different. Okay, neutrons will be different, like uranium 238, uranium 239. So what is different? That is also uranium, this is also uranium, but there are isotopic forms. Uranium 238 is a different isotopic form and uranium 239 is a different isotopic form. So how they are different from each other means they are having a different neutron number around that one. So an isotopes of a given element have a same number of protons but different number of this neutrons is called as the isotopes in their atomic structure. So nuclear materials according to the IAEA is at International Atomic Energy Agency. IAEA means according to this International Atomic Energy Agency, nuclear materials are nothing but uranium, plutonium and thorium. So all this matter, all these chemical elements will be having a atom. So atom is nothing but which is composed of nucleus together with a cluster of clouds, okay, electronic cloud which is revolving around the around the nucleus. So nucleus is composed of protons and neutrons. Protons are having a positively charged, neutrons are having a neutral charge. So whatever the electrons which are revolving around this nucleus is called as electrons, which will be having a net negatively charged. So whenever they are maintaining intact, electrons and nucleus are maintaining intact, that is because due to electrostatic force. Okay, that electrostatic force, or simply we can call as a Coulomb force. So these are the atoms which are there. Until here, if you find any difficulty or any doubts here, you can just notify me. Otherwise, I will move to the next topic. Okay, please respond. Shall I move to the next topic, or you have any doubts or something? Okay, if you are not responding, I will be the clueless.
Clear, sir.
Yeah, thank you. Then next one, this we have covered. So what are the various organizations, okay, which are conducting research or which are producing this nuclear energy? Okay, different organizations are there inside India. We will see this one. So first one will be the Baba Atomic Research Center, BART. You might be aware of this one, Baba Atomic Research Center. So that center is also there in Hyderabad, also R&D center. So this Baba Atomic Research Center is conducting these R&D activities, all these R&D activities in the field of nuclear power generation. Then next one will be the Tata Institute of Fundamental Research, TIFR. Bombay is there, here Hyderabad also one TIFR center is there. Okay, Tata Institute of Fundamental Research. Then next one is this Nuclear Power Corporation of India Limited. So NPCIL, popularly known as NPCIL, Nuclear Power Corporation of India Limited. Then next one is Union Carbide, Uranium Corporation of India Limited. So Uranium Corporation of India Limited, which is called as UCIL. Then next one is a Bhavini. Bhavini is nothing but Bharatiya Nabigya Vidyut Nigam Limited. Bharatiya Nabigya Vidyut Nigam Limited is called as a Bhavani. All these are the under the control of Government of India, under the agency called Department of Atomic Energy. Okay, Department of Atomic Energy, and one more center is also there in this Kalapakam, IGCAR, we will say IGCAR Kalapakam, which is Indira Gandhi Center for Atomic Research. So that is called as IGCAR Kalapakam, which is there in Chennai. Okay, all these centers will be controlled by Government of India, Department of Atomic Energy. So these are the organizations which are responsible to conduct a research on this particular topic, which is the nuclear energy production, and also responsible for the production of nuclear energy inside in the India. So all the R&D activities they will be undertaking, and production activities also they are undertaking this one. Then there are many pioneers. Okay, we have to remember them. So they are the pioneers. They are the first persons to conduct the R&D activities in India. Okay, that among them the first one is this Indian scientist and the gigantic, this we can say the educationalist. So he is a Daulat Singh Kotaria. Dr. Daulat Singh Kotaria is a eminent scientist who has been conducted a pioneer research, especially in India. So what we say this he's an educationist also. He was a scientific advisor for the Ministry of Defense, okay, Government of India, around the years 1948. From 1948 around he served 20 years. Daulat Singh Kotaria, he has served as a scientific advisor to the Ministry of Defense. Okay, Kotari fellowships are also there, which is named after his name. So he has a distinction of having both Padma Bhushan as well as Padma, we say Padma Vibhushan. Okay, both the awards he is having, highest civilian awards in our India, that is Padma Bhushan and Padma Vibhushan. Both he is having. So he has started this DRDO. He is the founder of many defense research and developmental organizations. You might be aware this DRDO we will call Defense Research and Developmental Organizations lab around India. Many labs he started. He is the founding member of that lab. He is the chief architecture of this defense DRDO labs in India. So like a novel Dockad laboratory. So later they have named this novel Dockad laboratory as Novel Chemical and Metallurgical Laboratory, which is located in Mumbai. Then Indian Naval Physics Physical Laboratory, which is located in Kochi. Then Center for Fire Research, which is in Delhi. Then Solid State Physics Laboratory, which is also in Delhi. Then Defense Food Research Laboratory, which is in Mysore. Then Defense Institute of Physiology and Allied Chemicals, Allied Sciences, which is located in Chennai. Then Directorate of Physiological Research, which is in New Delhi. Then Defense and Electronics Research Laboratory, which is in Hyderabad. Okay, we are having this one, Defense Electronics and Research Laboratory, which is there in Hyderabad also. Then Scientific Evaluation Group, which is there in New Delhi. Then Technical Ballistic Research Laboratory, which is there in Chhattisgarh. And he is a very eminent person. He has played a crucial role in framing the policies for this UGC University Grants Commission and various NSERT books, okay, CBSE books, whatever we are seeing. He has played a very eminent role in this one. So he's having a distinction of having the Padma Bhushan as well as the Padma Vibhushan, and he was the president of Indian Science Congress. Okay, nowadays the recent times also Indian Science Congress, in every year it will take place. Indian Science Congress. You can target to attend for this Indian Science Congress. Many Nobel laureates will be coming for the Indian Science Congress. Okay, then he was the president of this Indian Science Congress, and also he was the elected president for the Indian National Academy of Sciences. Okay, Indian National Academy of Sciences. He is the proud alumni of this Allahabad University. Okay, now in Allahabad it is there. He is the proud alumnus of the Allahabad University. So he has worked in this Delhi University also. Then next one is this Meghnad Saha. So you might be aware whenever you are learning this physics, okay, physics course, go sir maybe telling you this Meghnad Saha, about the Meghnad Saha, Saha Institute of Nuclear Physics, which is there in Calcutta, okay, which is named after this person only, Dr. Meghnad Saha. He is also one of the pioneer member to conduct a research in this nuclear physics. Okay, so he is a well-known Indian astrophysicist, and he is known for his work on this Saha ionization equation. He has found out the Saha ionization equation, and he is also a proud parliament member of India around in 1950s or something else. So then he is having a one of the institute which is called as a Saha Institute of Nuclear Physics, which is there in the Calcutta, which is named after him only. Um then what else we can say? He has worked in Calcutta University. He has worked in IISc also, Indian Institute of Science. Say this one. Yeah. Then you can Google out and see what is this Meghnad Saha and everything. Then next one is Dr. Homi Jahangir Baba. Okay, Homi Jahangir Baba, Baba Atomic Research Center. Whatever we are discussing now, Baba Atomic Research Center, that is named after him after his death. Okay, his death has been happened due to this plane crash. Okay, accidental plane crash. His death has been happened. He is the very eminent person to conduct a research in this nuclear physics. He is a popular Indian nuclear physicist known overall in India. He is the founding member of Tata Institute of Fundamental Research and as well as Baba Atomic Research Center. Okay, earlier the name of this Baba Atomic Research Center is Atomic Energy Establishment, which is there in Trombay, AEET, we will call that one. But after the death of this Homi Jahangir Baba, that institute has been renamed after him. That is Baba Atomic Research Center. Okay, TIFR, Tata Institute of Fundamental Research, is also started by this Baba Homi Jahangir Baba. So he is a proud alumnus of this Cambridge University. Uh, that one. Then next one is R.S. Krishnan. Okay, popularly known as R.S. Krishnan. He is also an Indian physicist who was the pioneer to conduct the experimental physics works in the nuclear energy domain area. He worked in the IISc Bangalore, Indian Institute of Science after C.V. Raman. Okay, you may be knowing this Sir C.V. Raman. Okay, after the retirement of Sir C.V. Raman, he was the HOD of the physics department in Indian Institute of Science. He is the proud HOD of the Indian Institute of Science physics department. So popularly, he is known as a R.S. Krishnan. So Rappal Sangameshwaran Krishnan. Okay, he is one of the scientists who has conducted the research. He is very closely acquainted with Sir C.V. Raman. Okay, so this was some of the details about the laureates. We should be proud of them, who are the doctorates, who are the proud doctorates, who has conducted the first research in India regarding this nuclear physics. So all these persons are very much eminent persons. You should remember always whenever we are learning. The next one is nuclear power in India. So what are the highlights of nuclear power in India? So what is the progress of nuclear power in India? So what are the highlights? First we will see the India is having the fifth largest. It is the fifth largest source of electricity. Nuclear energy is the fifth largest source of electricity. So apart from this one, there are we have a common conventional sources like steam power plants. Okay, then hydrothermal power plants, tidal powers, wind power, everything is there. So it is the nuclear power is the fifth largest in India, and there are 22 nuclear reactors in operation in India, and 7 nuclear power plants are there. So inside that 7 nuclear power plants, there are 22 nuclear reactors are there with a total installed capacity of 6,780 megawatts. Okay, MW is megawatt, and 7 more reactors are under construction with a combined generation capacity of 4,300 megawatts. So there will be an addition by 2025. I think the addition of this much electricity generation will can be happened. So until now we have this much of electrical capacity using nuclear energy, which is 6,780 megawatts. But by 2021 or 2030, we will be having the additional capacity of 4,300 megawatts. These are the highlights of Indian nuclear power generation. Then there are drawbacks. So that drawbacks are due to low capacity factors due to the lack of nuclear fuel. As I said you earlier, we don't have enough uranium reserves. We have a thorium reserves. Okay, that too we have to explore more and more. We have to exploit more and more the nuclear powers. There are many protests are there from the local people. Okay, from the local leaders and local peoples. There are many protests. They are objecting the construction of nuclear power plant. There are varied people, various ideology, various philosophies are there. There are many vested interests are also there regarding this one. There are many politics are also there. So okay, whatever the reason may be, due to the low capacity and non-availability of this nuclear fuel, as such fissionable fuel, we are suffering a lot in the nuclear energy sector, as well as protest from the local people to give a to give the land, okay, to acquire the land, as well as to put a plant in certain area. We have to get a local clearance. Okay, local peoples are protesting very much. So we have to find a safe places so that we can be constructing the nuclear power plants in India. So these two are the major drawbacks in India. Then there are 7 operational nuclear power plants. Whatever I have said you, the 7 operational nuclear power plants with the installed capacity of this much. So that is this plants are there, which is Kaiga, which is there in Karnataka. Power station which is there in Kaiga, which is located in Karnataka, which is operated by Nuclear Power Corporation of India Limited, which is NPCIL. So which is having an installed capacity of 880 megawatt. Then Kakrapar, which is there in Gujarat, which is also operated by this NPCL, Nuclear Power Corporation of India Limited, with an installed capacity of 440 megawatts. Then Kudankulam, which is there in Tamil Nadu, and also the Madras, which is there in Kalapakam. Okay, these two are also operated by Nuclear Power Corporation of India Limited, but they are located in Tamil Nadu with an installed capacity of 2,000 and 440 megawatts respectively. And Narora, which is there in Uttar Pradesh. Okay, Narora Power Station, nuclear power station, which is there in Uttar Pradesh, which is also operated by Nuclear Power Corporation of India Limited, NPCL, and which installed capacity of 440 megawatt. And one nuclear plant is there, which is there in Rajasthan, and which is also operated by NPCL with installed capacity of 1,080 megawatts. Then Tarapur, which is there in Maharashtra. That power plant is also operated by NPCL with installed capacity of 1,400 megawatts. So combinedly, we will get nearly 6,680 capacity megawatts capacity of nuclear power generation. This is already installed operational power plant. These are. Then there are under construction. There are 7 more under construction nuclear power plants are there in India, that are Madras, Kalpakkam. Another power station is coming, which is operated by this Bharatiya Nabikya Vidyut Nigam Limited, Bhavini, we will say that one. So which is operated by Bhavini with a capacity of 500 megawatts. It will be it is not yet ready, but they are stating as expected to be ready by 2020. Then Kakrapur Unit 3 and Unit 4. Further extension of that Gujarat power plant is happening, which may be expected by 2022, and with a capacity of 1,400 megawatts. Then which is operated by NPCL, Nuclear Power Corporation of India Limited. Then Gorakhpur, which is in Haryana, where this plant is also operated by NPCL, which will be constructed and erected and will be operational by 2025 with an installed capacity of 1,400 megawatts. Then in Rajasthan, same plant will be having a different units, unit 7 and unit 8. That will be operated by NPCIL with the installed capacity of 1400. It will be ready by 2022. Then Kudankulam, unit 3 and unit 4 in Tamil Nadu. That is also under construction, which is operated by NPCIL with the installed capacity of 2000 megawatt, which will be ready by 2025 to 2026 financial years. So all together combined, there is a capacity addition of 6,700. So this 6,000, nearly 6,700 is already operational, and this 6,700 will be coming into operation by 2026, 2025, and 2026 like this. Okay, these are the details of various power plants which are there in India. You can concentrate, you can Google it more about those power plants, what are their operating criteria, what are the job opportunities also you can find out. Okay, all these are listed out in this PPT, all the power plants. You can go through their website and search it, Google out what are the possibilities that we can work there, work for the nation, work for the building of the nation. Okay, everything we just you can Google out. Okay, until here, I hope it is clear. Nuclear power plants. Then next topic will be nuclear fuel reserves. Okay, what are the various nuclear fuels reserves which are there in India? According to this IAEA, okay, International Atomic Energy Agency, Vienna, Austria. So nuclear fuels are nothing but uranium, thorium, all these are the nuclear fuels, thorium and plutonium. Okay, all these are the nuclear fuels. So in India, where are these nuclear mines are located? Okay, there are two huge mines which are there in India. One is in Andhra Pradesh, another one is in Karnataka. So where is this nuclear mines are located in Andhra Pradesh? That is Tummalapalli belt. Okay, in the Tummalapalli village, that is called as Tummalapalli belt, it is located. And in Bhima basin, which is in Karnataka, they are located. There are certain advantages of these mines. So this Tummalapalli belt in Andhra Pradesh is known as one of the world's top 20 uranium reserves. Okay, much uranium reserves are there, but they are suffering from low quality, low grade uranium reserves. Okay, low grade uranium reserves. But this, see, compared to this Tummalapalli belt, Bhima basin is having a high grade reserve, but the quantity will be very limited. Okay, grade will be very high here, but the grade will be very low here. But the quantity is very high in the Tummalapalli belt. The quantity of this nuclear material is very low in the Karnataka Bhima basin. So around 44,000 tons discovered so far. So far, the research, the exploitation, whatever they have taken this exploration, so that has been estimated as 44,000 tons they have discovered so far. And they are expecting furthermore the 3 times more than this capacity. They are assuming that one. There will be huge capacity. Then next one is this Bhima basin. He's having a better grade natural uranium ore. Okay, compared to this grade is very better grade, but the smaller than this reserve is very small than the compared to this Tummalapalli belt. Bhima basin is quality is high, but the quantity is very low. So India's domestic uranium reserves are small, and the country is dependent on uranium imports to fuel its nuclear power plants. So we have to import the nuclear material from the outside the country. So the major supplier to India is the Russia. Okay, since early 1990s, the Russia has been the major supplier of nuclear fuel to India, and Kazakhstan is the largest supplier of uranium to India, providing around 5,000 tons during 2015 to 19. So we have to import that one. We have a ore. Okay, we have a secondary ore. We have a low quality, low grade ore that we have to purify. We have to be advanced in that field, purification, concentration, and everything. But right now we are importing them from the other countries like Russia, Kazakhstan. We are importing the nuclear reserves. And in the recent years, India has shown interest, okay, increased interest in thorium fuels. Okay, there is one advantage of this nuclear power is we can be using the secondary fuel, which is thorium also we can use. And fuel cells, fuel cycles, because of the largest deposit of thorium. Okay, we have a large deposit of thorium, around 5,18,000 tons. We have a thorium deposits, but the research has to advance more to use this thorium as an alternative fuel in the nuclear power generation. So in the form of this thorium is too located in the form of monazite in the sand, beach sands, as compared to the very modest reserves of low grade uranium. uranium is contained in very, very, very low grade. To purify that one, to concentrate that one, we have to invest a lot. Okay, the power generation cost will be very high. But whenever we find a alternative of using the thorium, it will be very much advantageous for us. So the thorium reserves are very huge in India, around 5 lakh tons it is there, but that too in the form of a monazite ore which is there in the beach sand, that we have to recover from the beach sand. So these are the nuclear reserves which are there in India. Some of the advantages and disadvantages of those reservoirs from Tumalapalli belt or Bhima basin. Okay, until here, if you have any doubts.
No, sir.
No, sir.
Okay, then next topic will be economic justification of nuclear fuel. So what is this economic justification? Economic, as you can see from the title itself, means how much cost it will be adding whenever we are generating the electricity from the normal coal-fired plants or the nuclear power plants. So we know that whatever the cost which is involved in any type of manufacturing will be divided into two types of cost. One is a variable cost or operating cost, we will say. Then next one is this fixed cost. So fixed cost is nothing but to erect a plant. Okay, to erect a plant, to replace some of the what we say this one, depreciated plants. Okay, everything will be coming under this fixed cost. Variable cost or operating cost is nothing but to run that particular plant. What are the auxiliaries? What are the various raw materials? Everything will be comes under the variable cost or operating cost. Okay, this total cost will be divided into the two components. One is the operating cost or variable cost plus fixed cost. So if you see this left pane will be the coal fired plant cost, whereas this right pane will be the nuclear power plant operating cost or fixed cost. So if you first one is the fixed cost. So the fixed cost will be low for the coal fired plants, but the fixed cost will be very high for the coal this nuclear power plant. Then the power generation for each so power generation cost will be 900 to 1000 per each kilowatt. Okay, per each kilowatt there will be 900 to 1000 which will be involved. Then the power generation cost in the nuclear power plants will be around 1200 to 1500 per each kilowatt will be costing you. Then the next one is a variable cost, or we can say the operating cost. So this fixed cost is also known as a capital cost. The variable cost is also known as a operating cost. So the operating cost of this coal fire plant is very high. Then the operating cost of this nuclear power plant is very low. Why? Because the quantity of the nuclear material required to generate electricity is very, very low compared to the quantity of coal which is required to generate a similar power. Okay, similar quantity of power in the coal power plant. Because of this advantage, the cost of variable cost will be very low in the nuclear power plant, but the variable cost is very high in the coal fired plants. Then the transportation. So transportation, see, usually the coal mines will be located far away, around 700 to 1000 miles. Okay, 1000 miles away which is located. And fuel cost, the coal cost is also very high. The transportation cost is also very high. But whereas in the nuclear power plant, the transportation and fuel cost will be addition, but the less quantity, the quantity, very less quantity we have to transport from the large, many places. But here the quantity we have to carry very much heavy quantity, many tons of coal we have to carry. But here very low amount of nuclear power is enough to transport or generate the electricity. Then in the coal fired plants, the required quantity of fuel is very high. Due to this required quantity of coal is very high, the transportation cost will be addition. Then in the nuclear power plant, the required quantity is 1 by 1 lakh quantity fuel is required. Only very limited in a fractional amount. Okay, compared to the normal coal power plant, the fractional amount of the fuel only is required in the nuclear power plant. That's because the transportation cost will be low compared to the coal power plant. So 1 by 1 lakh quantity, it is very, 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 very minute quantity compared to the normal coal fired plants is required. That is nearly 25 to 50 tons. Okay, for 1 lakh here 1 lakh what we say 1 lakh tons of coal is required, but here the same to generate a same electricity we require 25 to 50 tons only, but here 1 lakh tons is required. So because of this, The operating cost will be very high in the coal power plants, but the operating cost will be very low in the nuclear power plants. Then the net result is this total cost. Total cost is equal to sum of the fixed cost plus variable cost. Then the total power generation, okay, cost in the coal fired plants will be 3.7 paisa per every kilowatt hour. Okay, we will be measuring whatever our meter reading. Okay, that electrical person is coming and taking a meter reading, that will be measured in units. Okay, that units are nothing but kilowatt hour. Okay, this will be taking around 3.7 paisa per kilowatt hour. Then the power generation cost in coal fired plant is, okay, this is nuclear power plant. Nuclear power plant is around 3 paisa per every kilowatt. So this is the net result which can be obtained, which we can see the advantages of this nuclear power plant. This gives the economic justification of nuclear power plant in India, how important the nuclear power plant for us. It shows the importance from the economic reserves also, and also from the reserves also. We have a large thorium reserves, but the still the research is in basic, okay, very basis. We have to advance much and much. Okay, people needs to be aware of the advantages of this nuclear energy. Okay, but we have to look for the disasters also, we have to control them, the disasters also. Okay, this is what for today. For tomorrow, we will be covering this one, Nuplex. Okay, I request you to just revise the notes once again and come, or otherwise go to the Dryden page number 254. So in that one, flow sheet will be clear and some explanation is given there. Then revise and come. So Nucleus, as I said you, the nuclear agro-industrial complex means all the industries will be located at one place, like our special economic zone. Okay, SCZ Hyderabad, SCZ Visakhapatnam, everywhere in the major cities there will be some SCZs. Okay, SCZ here in GD Metla. Okay, many industries will be located at one place. So like similarly here, so all these industries, the pesticide industry, fertilizer industry, then power generation industry, then this distillation units, sea water purification unit, then the same water can be used in agriculture. Everything will be located in at a one place. So that is called as a nuclear agro industrial complex. So that we will be discussing in detail tomorrow. So better to revise and come for tomorrow. Okay, any doubts until here?
No, sir.
Okay, then thank you for listening.
No, sir.
Thank you.
Thank you, sir.